All right, welcome back. So this is another ALEKS topic. It's called Identifying Phase Transitions on a Heating Curve. This was a requested topic, so if you have different ALEKS topics that you're not finding that I have videos for, feel free to comment, leave a request, and I will try to get to it as soon as I can. Sometimes that'll be quick, sometimes it'll be longer, but I'll definitely continue to try to make ALEKS videos, as we go. So in this topic, I'm going to do two different examples just to give us a little bit more practice and see, some different ways the question is going to be asked. But the first thing we need to do is really get oriented with the actual heating curve, what it means, what the different sections represent. So the first thing I'm going to do is I'm going to label each different section of this graph, and then I'm going to talk about sort of what's going on at each different section. So this section number one, that's just sort of this, part right here. What that would represent would be heating up a solid. So the different sections of the heating curve are going to represent different physical changes or different physical states that we're going to find. And this first part, we're heating it up. It's going to a higher temperature, and this would represent the heating up of a solid. Step two is the phase transition. So phase transition from solid to liquid. So as we're moving along this line here, you'll notice that we're still putting energy in. So this axis here is heat added, kilojoules per mole. So we're putting energy in, but the temperature is not changing. That's a little bit strange, right? If we imagine if you're heating up a pot of water, as you put energy in, the temperature will change, the temperature will go up. But when we're doing a phase transition, this extra energy that we're adding, it's going into breaking down the phase, changing the phase from solid to liquid. So as I go across from this point here to this point here, across this two, I'm going a phase transition, so the solid is slowly turning into liquid. And then at this point here, all of the solid will have completely turned into liquid. So for step three, what's going on here is we're just heating up a liquid. And then step four is another phase transition. So when we see the horizontal parts of our graphs, that represents a phase transition. And obviously the lower one will be solid to liquid, and the higher one will be liquid to gas. So phase transition, liquid to gas. So along this section of the graph here, I'm going to be turning from liquid to, for whatever substance this is, liquid into gas. And then step five would be heating up a gas. And oftentimes we don't really worry about this step five, because if we get to this point, that would represent all of the liquid having turned into gas. And typically when we do that, you can imagine just heating a pot of water on the stove, all the gas is going to dissipate, right? It's going to go away. So let's go ahead and answer the questions real quick. So the questions say, what is the boiling point of X? So this phase transition, where it's going from liquid to gas, that's going to be the boiling point. So on this one, this looks like it's 60 degrees Celsius. So just reading, here's 50, this must be 60, that's 70. So where we see that horizontal line, that's going to be the boiling point. Down here, right here, that would be the melting point, going from solid to liquid, phase transition melting versus phase transition boiling. What phase, physical state of X would you expect to find in the flask after 49 kilojoules of heat has been added? So 49 kilojoules, that would be like right here. And at that point in this graph, basically we're doing the phase transition. So at this point right here, we would have heated up our liquid all to the boiling point. And at this point right here, all of the liquid would have turned into gas. So we're somewhere in between there, right? So if we're at this point on the graph, we're going to have liquid because not all of it has turned into gas yet. And we're also going to have gas because we've converted some of it, right? As we're going along this line here, that extra energy that we're putting in is turning the liquid into gas. Say, for instance, we were at this point here, like we were somewhere on this line, then we would only have liquid. So along this portion 3, that would only be liquid. Along portion 1, that would only be solid. In portion 2, that would be both solid and liquid, right? We're converting our solid, right at this point, that would be completely solid. This point would be completely liquid. But along that pathway, we're going to have both phases present. So here we'll have both phases present, liquid and gas. Let's do one more example really quickly, just so that we're, are clear. So in this one, what is the melting point? So now we're looking at the melting point. But again, the phases, right, the spaces that we're going to be talking about, they're the exact same as we were looking at before. So here, this would be, going from solid to liquid. This would be going from liquid to gas. So melting point of X, that's going to be here, minus 20 degrees Celsius. Just reading this lower horizontal line for the melting point, this would be the boiling point up here. And then what physical state would you expect after 36? So 36 would be right in this area here. So we'd still be on this part right here. So again, that would be liquid and gas. We're turning from completely liquid here, phase transition to completely gas here. But along this line, both of those phases should be present. For instance, if we were up here, we would only have gas. In here, only liquid. Down here, only solid. And then during the phase transitions, we're going to have both, whatever the phase transition is. All right, hope that helps. And like I said before, if you've got other ALEKS topics that you'd like to request, feel free, but give me some time. All right,